All right, so yesterday we started reviewing the quadratic formula again. We talked about, we first looked at the discriminant, which is the part of the quadratic formula that tells us what type of solutions and how many solutions we're going to have. If that value under the radical is greater than 0, we know we're going to have 2 real solutions. If it's less than 0, we're going to have 2 imaginary solutions. And if it equals 0, we're going to have 1 real solution. Then we got down into the quadratic formula. Again, you can see where that discriminant is part of the negative b plus or minus the square root of b squared minus 4ac all over 2a. A key being we have to have one side equal to 0 before we determine a, b, and c. So we got a couple examples in. I did tell you on this lesson we don't have any imaginary solutions. We're going to do a second part of quadratics that will get into imaginary solutions. I wanted us to just really practice the quadratic again, so there are no imaginary solutions in this first set. So we're at number 7, 5x squared equals negative 9x plus 14. Again, I need everything on the same side. So, and I'm going to do this in one step. I'm going to add 9x and subtract 14 from both sides, so that I can get that right hand side equal to 0. So I have 5x squared plus 9x minus 14 equals 0. And then now we can identify our A, our B, and our C. A is 5, B is 9, C is negative 14. So when we substitute into the quadratic formula, I have x equals negative 9 plus or minus the square root of 9 squared minus 4 times 5 times negative 14, all divided by 2 times 5. All right, then I'm going to put all of that that's under the radical in my calculator. So I have negative 9 plus or minus the square root. If I put in 9 squared minus 4 times 5 times negative 14, I get 361. And then that's all going to be divided by 10. As we saw in the previous problem yesterday, the square root of 361 is a perfect square. So this becomes x equals negative 9 plus or minus 19 divided by 10. And that plus or minus there means that's 2 different problems. I'm going to do one where I have x equals negative 9 plus 19 divided by 10. And x equals negative 9 minus 19 divided by 10. Negative 9 plus 19 gives me 10 divided by 10. So one of my roots or solutions is x equals 1. And then the other one, negative 9 minus 19, is negative 28 divided by 10. That doesn't divide evenly, but I can reduce them both by 2. So x equals negative 14 over 5. So the 2 places that my function is going to cross the x-axis is at positive 1 and negative 14 fifths. All right, number 8. 9x squared minus 2 equals negative 10x. Again, the first step is to add that 10x to both sides because I need one side equal to 0. So 9x squared plus 10x minus 2 equals 0. And again, now that I have one side equal to 0, I can identify my A, B, and C. A is going to be 9, B is 10, C is negative 2. So I have x equals negative 10 plus or minus the square root of 10 squared minus 4 times 9 times negative 2, all divided by 2 times 9. I will pause for a moment while you work out that value under the radical sign. All right, so we have x equals negative 10 plus or minus the square root of, what's that? What do we get for that value under the radical sign? $172. 10 squared is 100. Negative 4 times 9 is negative 36 times negative 2 is positive 72. So 100 plus 72 gives us 172, which is not a perfect square. So we do have to simplify this. We're looking for a perfect square that goes into 172. Now we have to look at 4, 9, 16, 25, 36, 49, 64, and 81. Do any of those go into 172? Four. If you, I know it's the last one on the list there though, but 4 times 43. So there's our perfect square. So the square root of 172 is really the square root of 4 times the square root of 43. So it equals 2 radical 43. So we have x equals negative 10 plus or minus 2 radical 43 over 18. So when I separate that out, I get x equals negative 10 plus 2 radical 43 over 18. And x equals negative 10 minus 2 radical 43 over 18. Now I can't divide and I can't combine the 10 with the 2 radical 43, but I can reduce. The 10, the 2, and the 18 are all divisible by 2. Negative 10 divided by 2 is negative 5. 2 divided by 2 is 1. 18 divided by 2 is 9. So what I'm left with is x equals negative 5 plus radical 43 divided by 9. And then the same thing on the next one. Negative 10 becomes negative 5. 2 becomes 1. 18 becomes 9. And I have x equals negative 5 minus radical 43 divided by 9. So that's my solution set. Negative 5 plus radical 43 divided by 9. And negative 5 minus radical 43 divided by 9. So that's just to show you they're not going to all come out to whole numbers. There are going to be some radicals in this first section. The only thing that's not in this first section is the imaginary part. We will get to that with the next set of notes that goes with this. I wanted us again just to review the quadratic formula before we added in those imaginary solutions with it. Number 9, 12x squared minus 10x equals 1. Again, we have to start off by subtracting 1 from both sides. So we have 12x squared minus 10x minus 1 equals 0. Because again, I cannot identify A, B, and C until they're all on the same side of the equal sign. So A is 12, B is negative 10, C is negative 1. So X equals, the formula calls for negative B. In this case, our B is already negative, so negative 10 plus or minus the square root. We're going to put that negative 10 in parentheses to square it, minus 4 times 12 times negative 1. This is all going to be divided by 2 times 12. So our double negative here is going to go positive. I'm going to pause for a moment while you do the calculation for what is under the radical there, and then we will check. All right, so again, we know we had the double negative, so we have x equals 10 plus or minus the square root of, what did we get for everything under the radical? $148, and that's all going to be divided by 24. Now, again, 148 is not a perfect square, so I need to see if I can find any perfect squares within it. So I'm going to look at 4, 9, 16, 25, 36, 49, and 64. Do any of those go into 148? Are they a factor? 4, you get 4 times 37. So 4 is our perfect square. So the square root of 148 equals the square root of 4 times the square root of 37 equals 2 radical 37. So x equals 10 plus or minus 2 radical 37 over 24. So again, we're going to split that off into the two equations with x equals 10 plus 2 radical 37 over 24, and x equals 10 minus 2 radical 37 over 24. And again, I can't do the subtraction on the top because I have a number with a radical and a number without a radical. So I cannot combine them, but I can reduce 10, 2, and 24 are all divisible by 2. So 10 becomes 5, 2 becomes 1, 24 becomes 12. So I get x equals 5 plus radical 37 over 12. And I can do the same thing on the other one. 10 becomes 5, 2 becomes 1, 24 becomes 12. So x equals 5 minus radical 37 over 12. So there's my solutions. All right, I am going to pause for a couple minutes while you complete number 10, and then we will come back and check our answers. All right, let's see how we did on this one. We're starting off with 6x squared equals negative 2x plus 88. So we needed to add the 2x and subtract the 88 from both sides so that we have one side equal to 0. So 6x squared plus 2x minus 88 equals 0. So A is 6, B is 2, C is negative 88. So x equals negative 2 plus or minus the square root of 2 squared minus 4 times 6 times negative 88, all divided by 2 times 6. So x equals negative 2 plus or minus the square root of 2,116 divided by 12. The square root of 2,116 is actually a perfect square. So x equals negative 2 plus or minus 46 divided by 12. So we get x equals negative 2 plus 46 divided by 12. And x equals negative 2 minus 46 divided by 12. So we have x equals 44 over 12. That doesn't divide evenly, but they are both divisible by 4. So x equals 11 thirds. And then the other one, negative 2 minus 46 is negative 48 divided by 12, which means x equals negative 4. So we should have gotten 11 thirds and negative 4. Yeah, I always move everything over to the left. With the quadratic formula, it would still work if you moved the 6x squared to the right because of the math that we're doing. But I just always like my standard form on the left and my 0 on the right. So I always move everything over to the left-hand side of the equation there to set up my standard form. All right, so again, you notice there are no imaginary solutions on this part. We will get into that, but this is just to help us review quadratic formula and the discriminant.